In the final part of this unit, we are going to discuss the corrosion resistance for aluminium object. From the reactivity series, we understand that aluminium should be more reactive than iron. So you can imagine, if a metal object is made by aluminium, it should corrode faster than the metal object that made with iron. It sounds reasonable, right? But the fact is, from the aircraft to the window film, we use a lot of aluminium. The reason behind is aluminium got a different properties towards corrosion after they expose to the oxygen and water. Similar to iron object, a layer of aluminium oxide will form on the metal surface. But different from the rust, the oxide layer by aluminium is impermeable to air and water. That means further corrosion will be stopped. This aluminium oxide layer acts as a protective layer and protect the aluminium from further corrosion. While compared with the rust layer, it's permeable to water and oxygen. That means the iron object will go further rusting until all iron are reacted. With this oxide layer, the aluminium object is corrosion resistant towards the water and oxygen. And scientists find that this oxide layer is so useful, they try to thicken this layer. This process is called anodization. With thickened oxide layer, the corrosion resistance of aluminium object is increased, but students should pay attention. The aluminium object will not become stronger after anodization. And the process is simple. If you refer to the previous section about cathodic protection, at that moment, the iron object is connected to the negative terminal of the battery. The battery will supply electron to the metal object, prevent it from lost electron or from corrosion. Now this time, we are intended to make the aluminium object lost electron, and that's why we should place our aluminium object in the positive terminal of the battery, which is called anode. Besides increase the corrosion resistance, the anodization brings another bonus to the aluminium object. And here you can see, scientists found that after anodization, the oxide layer is thickened, but within the oxide layer, there is hollow structure we call pore. Okay, this is not included in the DSE, just for your interest only. This perforate or pore structure allow scientists to inject some dye inside. So we can put some dye and make the aluminium object with any color you want. So you can see, for the aluminium object we use daily, some of them got nice colored. For example, the chocolate wrapping or a window film. Some window film are dyed into brown. Another example is the soft drink can. They can be dyed into nice pictures on that because the aluminium oxide allow the dye to adhesive on it firmly. So this is the end of this unit.